Okay, in this podcast, we're going to talk about an introduction to electrochemistry. So let's go ahead and take a look. So let's say I have this I have some copper sulfate. It's aqueous. It's dissolved in water, which is why it's so pretty and blue, right? Because copper plus 2 ions is what causes copper sulfate to be blue. And I put a piece of zinc metal in there, just a solid piece of zinc. What's going to happen, because zinc is a more active metal than copper, is I have the zinc metal, and it's going to react with the copper sulfate, aqueous solution, and it's going to give me zinc sulfate, which is also going to be aqueous, plus copper, solid copper metal. Okay, so if I look at what's happening here from a net ionic standpoint, I have the zinc solid plus the copper plus 2 plus the sulfate minus 2, which are both aqueous. And I'm going to get the zinc plus 2 plus the sulfate minus 2, which are both aqueous, in the copper solid. And of course the sulfates are going to be spectators and they'll fall out. And if we write the half reactions for this, we start with zinc 0, which is a solid, and it becomes zinc plus 2, and it has lost the 2 electrons to become the plus 2. And I start off with copper plus 2, which was aqueous, and it added those 2 electrons to become copper solid, which is 0. That's what's going to happen. So let's take a look inside in a particle diagram. So here I have zinc metals, zinc 0 in the strip. I have copper plus 2 ions floating around, they're blue, and 2 electrons are going to leave the zinc and combine with the copper plus 2, and in the process those copper ions become a copper atom, right? It's brown, it's copper solid, it's that reddish brown copper that we know, right? And the zinc is going to become the zinc plus 2, and it's going to be floating around in that solution. So I go from a copper solution, nice and blue, zinc strip, the copper has become copper solid, and this would actually be a reddish brown, right? It's a copper solid that plates out or precipitates out onto the zinc strip, right? So some of the zinc has gone away. This becomes a little bit smaller, and I have plated out these copper atoms onto the strip. Now, what if we could take advantage of this flow of electrons that we have that are leaving the zinc and joining the copper, and use that to harness that flow of electrons and create electricity? Because that's what electricity is, right? It's the flow of electrons. So here I have the same thing. I have, well, something similar. I have taken now and I have separated what's happening from the zinc with the zinc and what's happening with the copper. So I still have a zinc plate, right? I'm going to call that an anode. I have neutral zinc atoms, and it is in a solution of zinc nitrate. Okay? And what's going to happen is that the zinc neutral atoms, are going to lose 2 electrons and become zinc plus 2. And when it does, it's going to give up 2 electrons. And what's going to happen to those electrons? Well, it's going to travel up the zinc electrode through the wire, and that traveling through the wire is an electron flow. And isn't that electron flow also known as electricity? So it generates electricity, or a current, that we can use to do useful work. All right, so what happens to those electrons when they flow through the wire? Well, what happens is they go through the wire and into the copper electrode. So now I have these copper metal atoms in the electrode, and I have copper nitrate solution in this beaker. So what's going to happen is these copper plus 2 ions, these nice pretty copper plus 2 ions, are going to pick up these electrons, right? The copper plus 2 that are floating around are going to pick up those 2 electrons and become copper metal. Okay. And as a result, the zinc gets smaller because those zinc metals are going into solution, and the copper becomes copper atoms, and that precipitates out onto the copper electrode. So the zinc becomes smaller and the copper becomes bigger. Okay, because I'm adding the copper solid. And here the zinc is going away, the zinc 0 to become zinc plus 2, right? So you could ask, well, will this continue to happen on its own? Will it be spontaneous? And the answer is, if I didn't have this salt bridge here, which I'll describe in a minute, it would not continue to happen, because what you would see is, if I'm forming zinc plus 2 ions, these electrons are going to want to hook onto the plus 2. They're going to be attracted to the positive charge rather than flowing up. So we have to do something to control the charge. And what we do is we add some salt, some ionic compound in this bridge. We call it a salt bridge. Here we've used sodium chloride. We could use potassium nitrate or lithium sulfate, any kind of salt. And what's going to happen is the negative ions here, the chloride ions, are going to flow through that bridge and neutralize zinc plus 2. The purpose of the salt bridge is to balance the charge so that the electrons continue to want to flow up rather than flow into the positive. So it's going to neutralize those plus 2s. And on the other hand, the sodium plus is going to flow into the copper solution on the right, and that's going to neutralize the copper plus 2s, or the nitrates. So this doesn't become negative, and the copper and the electrons that are coming in attach to the copper plus 2. Okay, so that's basically what we call a galvanic or voltaic cell, or sometimes we just call it an electrochemical cell. Okay, so we're going to stop right there.